we will see another topic. So this is how a conductor is. So when you take a conductor, you have electrons present inside. So what are these electrons? They are the free electrons, right? You have a positive terminal here, negative terminal here, and there is an electric field which is directed like this. And due to the positive and the negative terminal, there is a potential difference that is going to exist. So if I take the length of the conductor to be L and the area of cross section to be A, right? These are the two things I'm taking. So what is going to be the volume of this conductor? So volume is going to be equal to A multiplied with L. Simple. So it's going to be A multiplied with L. Now the question is, suppose there are n electrons present inside the conductor. Suppose there are n electrons present inside the conductor. Suppose there are n electrons that are present inside the conductor. What is going to be the total charge present in it? Obviously, capital N multiplied with the charge of each electron. That is going to be N into E. Let me call this as 1. Right. Now, what is going to be the current that is constituted? What is the current that is flowing within the conductor? So what is going to be the current that is flowing within the conductor? It is going to be N into E divided by the time it takes. Why is it so? Because it is charge per unit time. So charge is N into E divided by time. Now the question is, how much time is it taking for an electron to go from the negative to the positive terminal? How much is the distance it is able to travel? Or how much is the distance it is supposed to travel to complete the circuit? So it is able, it needs to travel a distance of L, right? So if I say distance traveled by electron is going to be L. From here I can I say the time is equal to distance by speed. So what is the distance it is traveling? L. But we know the fact that on an average, each electron has velocity of Vd, which is a drift velocity. So that is the average of each electron speed, right? So it is going to be Vd. Makes sense? Right? So let me call this as second equation and let me call this as third. So what I basically did is I tried to calculate the value of current in terms of the charge per unit time, but we know that the total charge inside the conductor is capital N into E, and I calculated the time using the basic formula of distance by speed and wrote this. So what I'm going to do is take the third equation and plug it into the second one. If I do that, I'll be able to say that the current is equal to N into E. I'm not disturbing the whole divided by what is going to be the time, L divided by V into D. So this N into E into Vd, the whole divided by L, makes sense. So this N into E into Vd divided by L is there. Now what I'm going to do is, since area of cross section is getting related to a parameter of volume, observe. If I combine area of cross section with length, if I multiply both, I get a parameter volume. And when I talk about a conductor, conductor is basically cylindrical in shape. When it is cylindrical, it's a three-dimensional shape. Generally, for three-dimensional surfaces, when you speak in terms of density, you try to speak in terms of volume density. So how can I bring volume density here? By multiplying with A and compensating with A in the denominator. So I'll multiply it with A and dividing it with A. I hope you understood the logic of why we are doing this. That is more important, right? Why is it so? Because the conductor is three-dimensional. For conductor, for a three-dimensional shape, we define volume density. So A into L is going to give me volume. Am I right? So look at the way I'm going to write. Capital N divided by A into L, one parameter. E into this A, I'll combine it here, A into VD. The same expression is rearranged in this form. So A into L is volume. Capital N is the number of electrons. Listen to this very carefully because I'll be using two terms. One is number of electrons and I'll be using something called as number density. So for number of electrons throughout physics, for number, you always use capital N. For number density, you always use small n. So here, if you observe the number of electrons per unit volume is going to give me number density. So I will replace that with small n. Right? Into E into A into VD. So this is going to be the final expression for the current that is flowing through the conductor in terms of measurable parameters. So what I would say is this is the relation between the current in terms of drift velocity. That is why we saw drift velocity first. The next concept that we are supposed to know is this. So the heading is going to be the relation between electric current and drift velocity. Okay. We know that I is equal to NEA into VD. Right. If I rearrange this equation, I will be able to write it as I divided by A is equal to NE into VD. If you observe, this is basically the amount of current which is flowing per unit cross-sectional area. If you take this to be the conductor, there is current flowing through this. The amount of current flowing per unit cross-sectional area is what we call it as current density. So this is also density only, but the name given to this is the one which is in the numerator. What is it? Current per unit area. So it's called as current density, which is represented by the symbol J. Okay. What do you call this as? You call this as current density. And remember, current density is a vector quantity. So current density is a vector quantity. And what is going to be the unit of it? Obviously, unit is going to be, look at it and tell me. Don't look at the right side. Look at the left hand one. Ampere per meter square. So it is going to be ampere per meter square. So this is another important term that we are supposed to.